First one here, 2 times f of x, like that. What does that tell me I'm going to do the whole graph? Go ahead, Melissa. Yeah, so all my y values are now going to be multiplied by 2. So if I was at 1 comma 1, now I'm at 1 comma 2, right? So the effect is that it stretches this graph up taller than it was, right? So we're going to do all y values times 2. So you should have a stretched graph that kind of looks like that, okay? So just take each of your y coordinates and double them in this case. Okay. What happens when we put the same thing, but we put the 2 inside with the x like that? What is this really doing? Yeah, it's going to be my accordion shrunk together, because it's the opposite of what we see in there with the x. So I'm not actually multiplying it by 2. It's like I'm dividing it by 2 or multiplying by a half. So it's going to shrink. It's going to get that accordion squishing in. So you should have taken all of your x coordinates and cut them in half. So for example, this point right here is normally at 2 comma 1, but now it's going to be at 1 comma 1 because I take all those x coordinates and I shrink them by half. So this x coordinate was at 3, but now it's only at 1.5. This one was at 5, but now it shrinks to 2.5. Okay, same thing at each point. So where something changes, you just got to do that whatever your operation is. And it's helpful to know before you go into it what this should look like. So if you know, okay, this should look like my accordion squishing in. And it does. It's like I took the whole thing and I compressed it horizontally. Okay. The next one starts off the same. I'm still doing the f of 2x. So I'm still going to do that condensing, but then that minus 1 on the end of the next one tells me that I'm also going to go down 1. Right, so however you need to, and again, you could do this in 2 steps. You could first compress by a half and then move down 1. You could move it down 1 and then do a half. Since I had just done the half, I kind of had the points, so then I just took them and shifted it down to 1. So just make sure that it's clear what your final graph is, which one it is. So if you want to use a highlighter to do that, or whatever. What does the next one do? So there's a lot going on in this one. That's part of my graph. It's not being crossed out. So let's just go piece by piece. The minus 1 in there with the x is going to tell me to go to the right one. Okay. And then what is this negative 2 times the whole function? What does that do? Go ahead.
Double its size where you reflect it over the y.
Exactly. I'm going to take each y value, and I can basically do both of those at the same time if I just multiply each y value by a negative 2. Okay, so you might want to do these two in 2 different steps. That's up to you. Or if you feel comfortable doing them together, that's fine. But I'm going to take each y value, I'm going to multiply it by negative 2, and then I also have to shift it to the right one. So, let's just take one of these. So, let's just start with this origin point. If I multiplied that by a negative 2, I still get 0, but then I need to shift it to the right one. Okay, got it. If I take this point, his y value, he's at 2 comma 1, so his y value is 1 right now. I'm going to multiply it by negative 2. 1 times negative 2 is negative 2, so he moves down here, and then I have to do that shift to the right one. So this point ended up getting translated to right here. Okay, and you can do the same thing with each one. This one was at 3 comma 3. So I'm going to take 3 and I'm going to multiply it by negative 2. So now it's at negative 6. And then I have to take care of that shift to the right one. So that's basically what I'm doing for each dot. This was at 0. So 0 times negative 2 is still 0. But I have to shift it to the right one. Okay, so you can kind of see that it's done everything that I wanted it to do. Everything is shifted over to the right one, and it's reflected over that x-axis, and it's stretched. So all the pieces that I knew needed to be in there are there. Now, this next one's quite interesting. Let me try and cover up what I wrote. And what my graph looks like. Okay, this. What do we think this is going to do to everything? Well, let's imagine that the absolute value bars weren't there for a second. If you just have the negative out in front of the function, what does that do, Jared?
Reflected over the x-axis. I mean, y side. X. It's negative x.
No, you're right. Over the x. Yep. It's basically you're going to take each of your y values and multiply it by -1. So that's going to get me a reflection over that x-axis, right? But now I want to go ahead and take the absolute value of that answer. So what ends up happening is, let's say I had, well, let me just show you my picture now. Let's take this point right here. Right now, he's at 2, 1. His y value is a 1. So inside there, that negative means I'm going to multiply that y value by a -1. So now it goes down here. But then I need to take its absolute value. And the absolute value of -1 is +1. So I actually end up right back here. So that spot doesn't even change. Let's try it with this one. I'm going to take this one and I'm going to multiply it by a -1. So that means instead of being 3, now it's at -3. But now I need to take the absolute value. Well, is the absolute value of -3 +3? It's right back here. So this whole side doesn't change. It does, but it flips down here, but then it flips right back up. So my end result is that it hasn't moved at all. Let's look at points over here, though. If I took this one, which was a -4, I need to multiply it by -1, so now it's +4. But what is the absolute value of +4? +4. That's why it stays up here now. So this one did make a move, but then when I take the absolute value, it hasn't negated that move like it did on the other side. So this side goes right back up here. So same thing happens with all of these parts, right? So at first, I multiply it by a -1, it gets it up here, but then the absolute value of these are positive, so it stays. So my final graph is, and then this side just traces. I should do that one with a highlighter. So that's my final graph. Interesting, huh? I wonder if anybody got stuck on the last one. I'm going to show you the picture of what it should look like when you're all done, and then we can see if we agree or disagree. I wonder if you're thinking, well, mine looks kind of like that, except mine's shifted to the right, not the left. Well, so let's talk about this. Yes, you got to factor out that -1. If you have a coefficient in front of the x, right, you want to factor it out. It's even though it's a negative, right? Before, the ones we had done earlier where we took out a 2. But here, I can take a -x out, so I should take that -x out, and then I'm left with x plus 3, and then I have a +1. So now we can look at what each part does. So if I have the negative there in there with the x, that's going to get me a flip over the y-axis, because I'm going to take each of my x values, multiply by a negative, or divide by a -1, right? Because we are going to do the opposite, but it's the same with multiplying by -1, divided by -1, doesn't matter. But now that that's a +3, right? Normally, remember I have to do the opposite of what's really in there. So now, since that's a +3, I'm actually going to go to the left 3. But that +1 on the end, that doesn't change, so I shift everything up 1. So there's a lot of pieces to a lot of moving parts here. So let's just try it with the origin point, okay? So first I want to flip it over the y-axis. Well, lucky for me, there it is, right? It doesn't move. And then I need to go left 3, up 1. Left 3, up 1. So that's that new origin point. Has moved to here. Okay, let's try another one. Take this guy. I'm going to take my x value and I'm going to multiply by -1. So essentially flipping it over the y-axis, right? So it was at a +2. Now we're at a -2. So that's that. And then I have to go left 3, up 1. 1, 2, 3, up 1. So this point has now translated to here. Same thing with all my other ones. So do that flip, and then go left 3, 1, 2, 3, up 1. Does that kind of make sense? They can be tricky. So if you have a coefficient in front of your x, you want to factor that out. Because if you don't, right, you're going to probably shift it to the right 3. And you don't want to do that. Take out that negative, and then you'll see that it turns into a plus there. Okay. Let's stop this.